Felix, hi. Your video popped up there. That's good.
Yes, hi.
Good. Again, if anybody else wants to do an audio or video check, now's a good time.
Test.
I think I heard you just there, Jan. Yeah. So we'll give people a few minutes, including my co-chair, to get joined. Here comes Jonathan. Thank you, Kirsten. So Kirsten is willing to give occasional help. Anybody can jump in and help with note taking as well. It's a tool everybody can edit once you've authenticated to it. Jonathan, there you are. And do you want to send some audio, Jonathan, as well?
Yeah, I was just trying to share video. It wasn't happy with me. Hi, everyone.
So I guess we're at 2 past. We'll get started about 4 past, I guess, or 5 past, I'd say. Just give people a chance. I have one email from somebody asking how to join. So Jonathan, I'm not sure, we got slides from Jan. I don't know if you saw that, but those are now up and ready and Jan is in the room.
I didn't, but hang on.
And Karsten is willing to help out with occasional help for note taking, which is great. Is anybody else willing to try and help us keep some notes? We don't need detailed notes. Just basically, it's good if somebody volunteers to do something that we get their name so we can hassle them later. And Felix, you don't need to send video throughout the meeting. It's okay to mute your video and just have presenters kind of as we need them. Okay, so Karsten is volunteered to help with notes. Jonathan, I guess you and I can also try and keep up with people volunteering as they do.
Oh yeah, don't worry. I'll definitely make a note of any volunteers.
And I think we are being recorded according to what it says on my browser, which is good. That was when we were using WebEx for these meetings. I would always forget to hit the button. So Okay, we're at 5 past. I guess we'll kick off. So this is the usable formal methods research group in formation. We're kind of just getting started still. We agreed we had a meeting in Yokohama. We agreed we'd have an interim. I guess the main goal I would have for this interim is to try and tee up people starting to work on things, and kind of let's see if we can get groups of people going and stuff. My name is Stephen Farrell, by the way. I'm one of the co-chairs, and Jonathan is the other. So Jonathan is going to say hi.
Hi everyone. I'm Jonathan. I'm the other co-chair. Yeah, so I think we're going to have some very useful information this session, and hopefully we'll start getting some real directions for what we're going to do and where we can take this group.
Okay, we have some boilerplate stuff first. This is an IRTF meeting. The Internet Research Task Force also follows the IETF's handling of intellectual property rights and so on. So if you're uncomfortable with any of that, then that's probably, it's probably not a good thing. I'm assuming people are. We are being recorded. So those recordings are available later. Yeah, so basically, if you're sending audio and video, you're consenting to be in the recording. And again, like all kind of IETF and IRTF groups, we'd like people to behave, and I don't expect misbehavior to be a common thing in this research group, so that should be all good. And again, there's a bunch of links on those slides that are the real meat of whatever is meant. So those note well slides are really pointers to the policies. Again, just to say the Internet Research Task Force basically is focusing on what it says they're longer term research issues. We're not a standards development organization. We don't develop standards. We don't get to tell the IETF what to do, etc., etc. If anybody has questions about any of that kind of stuff, then drop them in the chat or jump up and down in audio if need be. Okay, so today this is our agenda, which we'll ask people to bash the agenda if they wish in a second. This is the intro part. We have Jan is going to talk to us about SSP-Verif. A colleague of Jonathan's, Bob, has done some work related to DNS. We have some ideas about sample problems. Jonathan has some information about usability issues. And I think I would encourage, unless the speakers prefer otherwise, I'd encourage people to jump in with any questions as we go. I don't think there's a need to wait. We're not pressed for time today, as far as I can see. To do that, there's a hand-raising tool at the top left of your screen, just below your name, where you can join the queue. I just did it to show you that. Then you pop in the queue, and we'll ask you to send audio and or video as need be if you have a question or comment. Again, if any of the speakers prefer to wait till the end, they should say that. Otherwise, please just jump on the queue as you feel the need to say something. And then if I think for me, the main kind of part of the meeting, which doesn't have to be an individual agenda item, but can be distributed, is the getting people to start doing things bit, where we want to try and see who's, a bunch of people clearly are interested in this topic. We want to start to see who's interested in actually doing what. Initially with a view to kind of leading up to a possible meeting at the July IETF, but obviously for ongoing things as well. And then if time permits, which it probably will, Jonathan has some slides on delegated credentials that he did not cover in Yokohama because we didn't have time there. That's our agenda. Jonathan, I don't know, did I forget something or miss anything? Or okay, no. And does anybody have comments to the agenda, things they want to change, add? Feel free to suggest changes or additions. That's entirely fine. Felix, you're in the queue, so.
Yeah, it's maybe a minor thing, and we can discuss it later. But what I would be particularly interested in the bullet point for getting people to start doing things. I lack a bit of an imagination what possible deliverables or artifacts could be that come out of this research group, and I'd like to maybe discuss that as a possible more concrete thing to discuss than start doing things.
Sure, that's a very fair question or comment. I guess typically IRTF research groups can produce, people produce papers in a normal kind of publishing kind of arena. It can be the case that we may want to produce some internet drafts or RFCs. That doesn't have to be the case. I think for this research group in particular, one of the things we should think about is whether some of the work might be nicely published in the context of the ANRW workshop. But yes, I think that's a good point, and probably one that we should think about as we go through the agenda, as what kind of artifacts might this produce and how might we handle them. Jonathan.
So in my usability issues in formal methods slides, I do have some concrete suggestions, but just to give a quick preview, I think one of the really key things that we don't have at the moment are intermediate training examples for a lot of the tools. A lot of the tools that I've used, at least, have one trivial example and then go straight on to incredibly complex, very hard to replicate without many years training example. And so something that this group could work on, and that Stephen will talk on later, is a sample problem, or maybe even, eventually a suite of problems. And you would then say, oh, I have this new tool. Here is each of those problems solved in my new tool, or whichever ones apply. So that there's a sort of increasing path of difficulty so that people can learn how to use these tools. So one thing might be training materials.
Indeed. Again, thanks, Felix, for that comment. Anybody else have a comment or agenda bashing type thing, or something they would like to interject now? If not, Jan, I can present the slides. I can do the button clicking on the slides for you, or I can actually hand you control if you prefer. So let me just switch to your slide deck. So Jan, if you want to start, yeah, there you go. And would you like to control the slides, or would you like me to hit the buttons for you?
Yeah, I think it's easier if I control them. Thanks.
Okay, so I'm passing you
perfect.
control. You should see the slide number thing at the bottom of your screen.
I do.
Great. And again, we're not hugely pressed for time today, I don't think so. Don't feel a need to rush, but I think we budgeted like 15 minutes or something like that. So I shall stop on the video and over to you, Jan. Thank you.
Yeah, thanks for having me. Hi, I'm Jan. I'm working with Chris and Christoph on SSPVerif, which is about verifying state-separating proofs. And a lot of you may be wondering what state-separating proofs are. And state-separating proofs are a method for modularizing computational cryptographic security proofs. In cryptographic security proofs in the computational model, you usually say, okay, we have an adversary and they're like computationally bounded. And if we set them into this game, into a cryptographic game where they interact with cryptographic primitives, they have to tell apart, is this like the real primitive, or is it just like the ideal primitive that just actually gives them random numbers all the time? And then we say, okay, they have a certain bound on their success probability. And state separating proofs take this concept and try to modularize this to make a lot of the proof steps, specifically the reductions, a lot more simple. And for the purpose of this talk, I'd like to use hybrid encryption from Chem and Dem as a motivating example. Hybrid public key encryption basically is you have a public key from a receiver and you want to send them a message, and then use the public key, encrypt the message with the public key, and give them the ciphertext, and then they can decrypt it. In hybrid encryption, you use two steps. First, the asymmetric step, where you just like get a key that you can then use a symmetric encryption algorithm for, which is called DEM, like key encapsulation and data encapsulation. And if you just use Chem and Dem in like a modularized way, modularized in a way that makes sense for state separating proofs, you would end up with something like this, where on the left you see basically the oracles that the adversary can call, like invoke on the individual pieces called packages in SSP lingo. So they can generate new public keys, and then they can encrypt both the keys and the data. And this is all neat. The problem is that like this isn't really compatible with the HPKE interface, which just has like a single encryption, a single decryption oracle. So what we can do is we can just like put an adapter in between, and then yeah, there's just a single function. It just calls them both sequentially in a way that makes sense for HPKE. Now, in state separating proofs, the neat thing is, like I said, the reductions are supposed to be very simple. And in the way that the assumptions are formulated, we can now just actually go and say, okay, we know that this is basically the same, like the real chem, the game in which the chem is real is basically the same, or yeah, indistinguishable from the chem in which the game in which the chem is ideal, which means it just returns random ciphertexts and produces random keys. And in such a setting, now that the DEM consumes random keys, that one also matches the assumption, and now the DEM can also be idealized, which means it will just produce random ciphertexts, but still decrypt fine. So this is all neat and a very practical, very handy thing for working on proofs. But the problem is, what we're actually dealing with is the HPKE security definition, and that lives in a single package, and it's not modularized at all. And we still have to like somehow show that we're actually talking about the same kind of security. Like we have to show that the security definition we're working with in the modularized version is the same as the monolithic. Yeah, Stephen, do you want to go now or after?
Oh, after is fine, but I just had a clarifying question. So HPKE here, you are referring to RFC 9180?
Roughly. I think it used to be called like integrated encryption scheme as well, or ECIES as well for elliptic curves. It's just like the general. I think I'm using the term because IETF use that term, but I think it basically is that. I would have only looked at like that RFC briefly, but I think it basically is that, yeah.
Okay, great, thanks.
Right. Okay, so this we tried like there were like several approaches to do this before SSP Verif. One approach I did in my master's thesis was that I tried to inline all of the code and then show that basically it's the same in the monolithic and the modular version. That was a pain. And so then more formal methods, but on paper, were also used by other researchers, such as Chris and Christoph. And yeah, so now it just turned out again and again that this was a very annoying proof step. And what we wanted is something that is easily verifiable, and we don't have to manually write and keep consistent between changes a whole lot of code across a whole lot of pages. So we started working on SSP Verif. As a user of the tool, you would write something that looks somewhat close to pseudocode. That stuff is then parsed, and you would generate SMTLib code, including the SMTLib versions of the package code that you've written in pseudocode, as well as some helpers. The user then writes invariants that are all consumed, as well consumed by the tool, by SSP Verif. SSP Verif then invokes the SMT solver in a certain way in order to like show that the two things are equivalent. So this is like the most complicated, I would say, part of the whole thing, of the tool. What we also do is we type check the code. Well, maybe this is the most complicated one. And also we also show that the compositions are also type checked, such that basically to check all the packages are connected in a sensible manner. And we not only support equivalence steps, but also reduction proof steps. So basically the goal is to have like a start to end proof encoded in SSP-Verif. One thing we're working on is better error reporting. We're working in Rust, so as developers, we're used to very good error reporting, which is not something we currently can claim to provide our users. Luckily, we are the only users currently. So, and yeah, we're also working on tools to give better insights into proofs and why the proof doesn't currently does or doesn't pass. Current challenges is that the users have to be really fluent in SMTlib for several all over the code base. Basically, they're dealing with it, and dealing with for loops also is a bit tricky. But I think we have a good approach, and we haven't been able to like really use it, but we're on it. And as a case study, we're formalizing the proof of Yas garbling scheme provided by Polska and Oexner on paper. We're now formalizing this in the tool, and we also want to do something with key exchange. Finally, the hopes for the future we have is that we can verify SSPs for very large protocols. I think this is something that also sets it off from EasyCrypt, which is more about like smaller systems, but in a more fine detail. Like it seems to capture time, is like side channels and timing and stuff like this. I think stuff about C code even. And this is not something that we're really dealing with. We're like looking at the high level at the moment. Yeah, I think that was it from me, and looking forward to questions. Yeah, Jonathan.
So this is super interesting to me. I came from a Xamarin background, so I looked at TLS 1.3. And one thing that's really hard to prove when you're doing bigger size things is how all of the different pieces link together, and how the state you're guaranteed, whatever you're guaranteed from, this key derives this key, which means that this message must be tied to that thing. And your proofs look all very separate. Is there a nice way of showing how you pass state between each part of them?
So basically, we say. So I mean, Xamarin works very different, right? Xamarin is like the symbolic model, and if you look at the picture here, basically what we do is we say before, like for all possible states where before an Oracle invocation, the state satisfies the certain invariant, then we invoke the Oracle, and then the response to the user, like to the adversary, is the same. And we also have like a relation between the state of the system in the real game and the ideal game. And if it's like an equality sort of equivalence sort of relation. And if that is the same, then the output is the same. And then the target state of the system is also matches the invariant, and also again will, for both systems, fulfill that equivalence relation. So basically it's more like an invariant based thing. So we don't really keep track of states individually. It's more.
So you can't, or well, can you? So in TLS 1.3, just because that's what I'm familiar with, you don't get certain authentication guarantees until you've received the final finished message. So can you say, cascade back up the stack, say, we know we have this authentication guarantee at this point, because later on, we know the finished message was accurate. I think that's how the Xamarin proofs works.
So okay, so firstly, that's a good point, kind of like adaptive properties are kind of annoying to like pass the information across several packages. That's a absolutely good catch. I haven't modeled these authentication properties in state separating proofs yet, but I think for authentication properties it's usually fine. You should be able to do that. But you would somehow need to pass the state from one point to another. But I think authentication is also not necessarily what this tool is best at, because it's more about protocol flow and protocol logic, where Tamarine is amazing. And I think kind of privacy properties and domain separation, this kind of things, as maybe more strengths of this kind of techniques. But question is like how to compose them nicely.
Very cool, thank you. Are there other questions?
Yes. So what a very nice talk. I had a quick look at your GitHub. Is the code available somewhere?
As of yet, it's not public. We can work on that.
I'm curious when it comes out. And the second one is, you say, I mean, the last line of your slide, you say it's complementary to EasyCrypt, but could you imagine making EasyCrypt a backend? And I guess the same question holds for SS Proof.
This is something that we discussed. I think it should maybe be an avenue, but so far we haven't explored it in depth because we still had so many things to do. I don't know. I think it would definitely. I think it would be an option. I think the question that would need to be answered is, what are the specific benefits of using these tools? Maybe just being able to generate code in that language might be. Yeah, I think what would happen is that we generate, instead of generating SMT code, we would generate SS Proof. I think it's in Haskell, right? And
SS Proof is in Coq and EasyCrypt is in.
Right. Yeah. Like I was just like some ML language. Okay, and EasyCrypt is completely different. Yeah, I think that would be something that's possible. Yeah, I think the question is like, what do you want to gain from this? And I think, yeah.
I mean, if you go to EasyCrypt, you could verify. I mean, both of these tools would give you much more possibilities to connect to running code, for example. That's one of the things I presented last time. Both EasyCrypt and Coq would allow you to generate Jasmine code, for example. And you would, I mean, all kinds of other properties of the computational model you could do there. And I don't think you have them in SSP Verif, do you?
Well, the properties of the computational model arise from SSP, right? And we only use symbolic things for showing equivalence, and the reductions are done by just showing, okay, yeah, basically the assumptions match, and then you can rewrite the graph.
But could you prove anything about Rust code, for example?
Oh, no. We were looking into Hackspec, I think, which is like this subset of Rust, but this is something that seems for our purposes way too deep in the details of like, okay, now we have a byte array, like an array of U&8s that is this long, and this was not at all what we were getting at, because we were like modeling global protocol state and not like looking at individual implementations.
But in the end, you would like to have a complete proof about, running code at some point.
Yeah, I mean, like, this is an interesting feature, but it hasn't been one that's been guiding the development of this tool at this point.
Yep, and I understand. it's just something that might be interesting in the future. Thanks.
I think we had Felix in the queue. Baz, I'll just drop you off the queue if you had a different question, you can rejoin the queue. Felix?
Oh, thanks. Yeah, keep on right. Yes, I see. Thanks for the succinct talk. My question connects a bit to what Bas just said. I wonder what exactly you are proving things of. Like you say, we prove things about code. What's your domain?
I'm not unsure. I completely understand the question. So I think there's like several steps. One thing, like the core thing that we need SMTlib for is proving that the code of basically input-output equivalence in a way between two different implementations of supposedly the same functionality are actually the same.
Okay, so you're doing code verification of a crypto library.
I'm not sure what like code verification, if that is a technical term. I'm not really deep in like formal methods. I would and just like winged it in a way.
Yeah. What I wonder is, there are people who come up with cryptographic primitives, and then they do game-based proofs about the cryptographic about the primitives. Then you have people implementing these primitives. You might want to prove something about those. I didn't quite like. I wonder what is in these boxes that I see on the slide.
Right. These are games. These are cryptographic game. This is like pieces of a cryptographic game, and the composition is the game. Like the top thing is a game and the bottom thing is a game, and we want to show that these games are actually equivalent.
Okay, so in the end, you have a theoretical result.
Yes.
Okay, great, thanks.
Hi, so I'm up next, I guess. This is fun. Again, I think I'm just going to go a bit further from the previous question. You said that the source is a bit like pseudocode, and that interests me a lot. What does it look like? What is this pseudocode?
Okay, let me try to find an example. It's a language we made up and then hacked together the parser. Yeah, that would have been a good bonus slide. I agree.
You don't have to search for it right now, but that, yes, indeed, I mean, that would be lovely to see, because it's also the way to see how the connection is between the kinds of standards that are being standards at the CFRG, how you would link it to something like this. So maybe it would be nice to have such a kind of semi-formal pseudocode language, which people could then use directly in the standards or in their papers or whatever, which could then feed into your tool.
Right.
So that would be an interesting thing to look at. So the moment this is, maybe when you're ready to kind of make public some of the results, you could send an email on the mailing list with a link to stuff, and that would be quite nice for us to look at that point.
Yeah, sure, definitely.
Okay, we appear to have joined the queue. Any last questions, or shall we move on to the next talk? Okay, the queue's staying empty. Thank you very much. This was really interesting, and we're going to have Bob presenting. Hi, Bob. Do you have control of the slides?
Do I?
That was...
Oh, I do. Excellent. Okay. I've never used this presentation program before. So I'm going to talk a little bit about some experiments I was doing with Rosette. Rosette is a augmentation to Scheme/Racket, and was using the Z3 SMT solver. So I wanted to say something about background here because I'm kind of more a representative of your target audience than I am someone creating the tools. I've been an engineer for a long time, although I'm currently in research. I don't have any training in formal methods, but I do have some awareness of them. I was at SRI CSL before I went to Cloudflare Research and was surrounded by formal methods people. So I saw some of what they did, but I never kind of understood what could I do with it in day-to-day engineering kind of things, as opposed to trying to do something exotic like prove the correctness of an entire DNS server. That seems hard to me still, but any kind of proving of anything is oftentimes better than nothing. I have used formally proven things in the past that other people did proofs of, but at any rate, as a part of my current research, I wanted to be able to have proofs in a completely different area, and I decided I needed to learn more about this topic. And I realized that things have changed a lot since the last time I even, considered what it could do. And I remembered we had an intern last year who said that Rosette was really pretty and well documented and high level. So I decided to just try it and make some problems for myself that I thought were substantive problems that I could see what could be done with it. So that's sort of where I'm coming from. And I mentioned DNS Python here just because I'm using part of it as an example, not because it's super important. So the thing that I was looking at is a method in the name object called fullCompare, and its job is to compare two different names and return some relation information on them. And there's quite a bit of relationship information. There's sort of where they are in the tree, superdomain, subdomain. Maybe they have a common ancestor, but are not direct parent and children, or maybe they don't have any relation at all. And they're kind of complicated because DNS Pythons let you have both fully qualified names, that is names ending in the root label, and also partially qualified names that are relative to some unspecified origin. In addition to the tree relationship, there's also an ordering within the DNSSEC ordering, and it's also useful to find out how many common labels you have for other operations. So this is what I'm looking at. And why did I look at this particular thing? It's because I understand the subject area. This particular method is important in the context of DNS Python's library. It's not important in the world, but this name comparison thing is used by a lot of stuff, and it's very important that it's right. I'm not worried about it being wrong, but I thought it would be a good problem. And it's also complicated enough to be interesting to me, and I just didn't see going into this how it was going to work. And it has good test coverage, but I'm never really happy with unit tests because I never really know what I missed in a unit test, right? So how did I approach this? Well, the DNS space seemed too complicated still, right? A DNS name is kind of a sequence of labels, and it can be up to 255 bytes, and the labels are strings, and there's case-insensitive comparisons, but none of this was really super important for is the actual algorithm in fullCompare right? So I simplified things into something that was much happier for Rosette, which is I'm modeling DNS labels just as integers, because all I really care is that they have an order. And I simplified a domain name instead of being a much longer and complicated list of labels. I just said it's going to be between 0 and 3 labels. And then I took the fullCompare function from DNS Python and rewrote it into a tail recursive function in Rosette. And I did it as tail recursive just because it always makes progress that way, and it felt better as a mathematical argument, right? That if I can get this step to be proven, then that would generalize better to the full problem of longer, more complicated names. And so the sample problem I have was to check for consistency, which is like if A is a subdomain of B, will it say that B is a superdomain of A? If A equals B, will it say B equals A? Those sort of things. So it's a simple test, right? This is like an exercise for me, not anything earth-shattering here. And this will be too small to read, but I just put it here. You can see this is basically doing the kinds of check that I was talking about for each of the cases. And I'll say a little bit more about what this meant rosette-wise later, but let me just get to the important bit. So here, these new name things are just basically generating any name from the space of names between 0 and 3 labels. And it's going to exhaustively check that this assertion that the names are consistent is true for this entire space. And I run it, and it returns unsat. And this is really an epiphany for somebody like me, because this is much stronger than a unit chest, right? Like I've just shown it, the SMT checker, it just shown there's no way to make check false. And so in that entire space. So this was really exciting for me. And the takeaways from this, although this problem was overly simplified, perhaps, I still learned a lot about the algorithm. And it will generalize to the larger problem. So I leave this, even though I haven't necessarily proven the full original program correct, I still leave this feeling much better about the algorithm. And I think that this could really make a big difference in day-to-day engineering, to the extent that I think that this should be added to people's toolboxes, because even if you only do small critical fragments of things, you're still creating a really meaningfully better experience than what we have without it. And it was really easy to use. Rosette sort of basically exposes this notion of a symbolic variable, and verify and solve. And verify and solve are kind of the same thing, just one is looking for exceptions to the thing and others looking for a solution. But it was really handy because I actually made bugs in my first translation. And so I confidently check in verify, and it says, oh, here's the model of where you made a mistake. And now I know exactly what's wrong and can plug that in and see, and then fix it. And in another example that I'm not describing here, I did a much more in-depth kind of explorations of the space. And that really worked for me as a developer, in that the way I work, I like to explore things and do a lot of hand testing just to sort of learn what the space that I'm working in is. And having something that can come up with examples or prove that there are no examples, just it was a real power lift, I thought, and a productivity enhancement. So anyway, that's I guess I have one more slide. Or that was it. That was it. So I'm happy to take questions as your possible target audience.
So Wes, I think you're first.
Great, thanks. Sort of two questions are somewhat related. One, I find this, presentation fascinating. Thanks for the information. I now need to go read a whole lot of documentation on Rosette because I didn't know anything about it. But I'm curious about the usability level, right? It's clearly a programming language. It's clearly, Lisp oriented and things like that. And so what I'm wondering is, how easy, was it for you to spin up and be able to do this? And let me tie that to more concrete example of, you talked about it, being better than unit testing because it can verify that you couldn't have done anything wrong, right? It's not just that you're testing one scenario, you're testing them all. Almost seems quantum-like. What I'm curious about is, how much effort does it take to produce a set of things that make you feel confident that you haven't missed anything? So unit testing is very small and microscopic in terms of the types of things that you're testing, whereas, what I think we really want to do is test functional testing that is more user-oriented, end-to-end, high-level kind of concepts, and it doesn't seem like that's entirely possible. And sorry for the long-winded question.
Yeah, I don't think I can say about the high-level thing. I will say that higher level testing is possible. I saw this at SRI, although I wasn't writing it, but I saw a more complicated end-to-end orchestration of something. So I think that there is some possibilities in there. So back to, I guess, how it was for me with the coding. Well, first of all, I did have to translate into Scheme, which didn't bother me because I learned Scheme at the very start of my education in college long ago now. And I always liked it and remembered it. So that didn't bother me. I think that if this was going to go for a bigger audience, it would be nice if you didn't have to do that translation. But the thing that was really nice about Rosette is that it's basically an overlay on top of Scheme. And you can imagine doing this kind of overlay on top of another language. I mean, the interface to me as a programmer was, I write my normal program, except that I can now use these symbolic variables as well as regular variables. I can now encode some assumptions, which was also familiar to me because I've done design by contract type programming for decades. So you assume, assert, assert. And so writing that wasn't weird for me. And then the nice thing is you just call verify on an assertion, and it checks that, there are no counterexamples to that statement, whatever that function is doing, based on whatever assumptions that you've limited it to. So, I would have assumptions like assume that the list is between 0 and 3, that kind of stuff. But it still felt very programmy. Like I never had to learn about how SMT solvers work. I never made any translation I'm aware of what this SMT lib thing is because I poked around a bit, but I didn't have to think about what the translation was into that. And gosh, the translation was pretty complicated. I looked at a couple of them. It wrote I think it had like 300 variables and one thing after it enrolled everything, 300 terms that it was checking. But I didn't worry about all that. I'm just sort of living in this augmented programming space where I now have these tools to go simulate the entire space of inputs and outputs. I still think knowing how to limit things so that you don't run into limitations of the solver is probably going to be relevant. And I don't know. Did that answer some of your question?
Yeah, it did. Thanks. That was definitely helpful, and it was certainly sounds like it was helpful. You had a lot of background too, but I'll let others go further. I could talk to you for half an hour, I think. So.
Yeah.
Oh, this was a gem of a talk. I really enjoyed that. Thanks so much for this. I'm coming from the other side of this working group where we're building tools, and so this is very valuable for us to hear this kind of thing, I think. And one of the nice things about your example, although you picked it as a starter example in some sense, is the fact that it's small, it has a clear spec, and it's self-contained. And this is rare actually for us, because at the end to publish papers, you end up publishing things about large, huge protocols with lots of dependencies and stuff. And it's not clear that it's actually accessible or usable because you're always focusing on the big thing. So do you think, from your experience as engineer all these years, do you think it's possible to build a corpus of small, interesting examples that would be good to verify? And do you think such things exist? I mean, full compare is one of them, but is there other things like this which you could point out and say, that one?
I'm sure that you can come up with that because, like I say, this was only one of a couple examples, and my other examples were in a completely different domain, and it was a domain that I didn't know as much about, so they were actually more valuable to me as an exploration tool. Like I went in and purposely made some mistakes in order to discover them, right, to see how the tools worked. But I also discovered that I'd made a whole bunch of other mistakes that I didn't mean to make. And so because so I think it'd be a really good tool in an architecture phase if you're designing things that you can learn the space better and learn what your assumptions are and that kind of stuff. And one of the things I'm definitely trying to say today is, while I don't have anything against proving full, large, complex systems, I'd love it if you had a completely provably correct name server. I just wanted to say that it's one of these things that it's not an either or, and you don't have to do everything. And the state of being for a lot of things is so low that anything is better. You know, like to get from I hope that my unit case covered everything to knowing that my tests covered everything is big, because not all parts of my program have the same sensitivity. But you know, like if I was doing network security code or something, I would really want that to be as nailed down as possible. And I would be happy just to have it proven, even if nothing else could be proven. And I believe that these tools are sufficiently mature now, and maybe getting to the point of sufficiently high level that they could be accessible to more people.
Yeah, that makes complete sense. I think one of the big challenges, even from the tool application point of view, is even to extract out a piece of code, like you were saying about network security or whatever, and say we want to verify just this piece, is quite hard often, because just
Yeah.
fact like this self-contained bit. Yeah. But anyway, thanks so much. This is very useful.
Hi, Bob. Thanks again. I think this is really useful to see. Can just two quick questions. One is, can you kind of give a sense of how much effort it was to kind of do this work? And second question is, assuming somebody was willing to kind of try and document this in a way that others could learn from, what way would that be best done, would you say? And would you be willing to do it and send the results to the list if you're going crazy? But I'm kind of interested, how much effort and like how would you kind of write this down so other people could reproduce the same kind of thing somewhere else?
Yeah. Let's see. As far as effort, I think I spent a couple days, but no more, on the actual on all the modeling that I did. It took a little while to get going, because the learning curve is pretty steep at the start, and I didn't even have the tools set up, right? So like I had to get Racket installed in its IDE, and then install the package, and then I had to read all the documentation to learn about symbolic variables and things. But the documentation was really good, and in particular, it gave me a really great tool. This notion of, I mentioned it in the talk, of picking a list between 0 and 3 things long. You know, that list type is not a solvable type itself within Racket's or Rosette's terminology, but you can build up a list of things like that by sort of parameterizing it by things which are solvable, like integers. And it was smart enough to do all the translation for that, provided that you didn't make things infinitely long. And so it wasn't too bad a learning curve, but I guess I'm maybe was ready to hear it too, or ready to do it for some reason. But and I would be willing to write up my experience.
That'd be great. Yeah, thank you. Nikita, far ahead. So Nikita, are you in the queue or having audio difficulties, or you can, if you are having audio difficulties, you can use the chat feature to. Okay, there you are now. No audio. Okay, so Nikita said she's having trouble with the microphone, and we'll ask offline. Any other questions for Bob? Bob, did I hear you actually just promise to say that you probably would write something like this up and send it to the list at some point?
Yeah, I think I did say that unwisely.
Fantastic. That's great. And I hope our note takers caught that.
Jonathan won't let me forget.
Good. Any other questions or comments for Bob? If not, thanks, Bob. That's pretty interesting. And I think it's me next. So this is a kind of a similar thing, except obviously less well done and more kind of flaky. But we had, as we were chartering this research group, we had, the idea of possibly having sample problems, and maybe Bob has just kind of given one particular one related to DNS. But if we had one or a few sample problems that we could document that were tractable and where people could, as Bob just described, try and make use of the kind of formal methods and see how they work and be able to explain to people how to use them, I think that might be useful. So I had an idea for this, for what might be interesting. Perhaps it's a crazy idea, but the basic concept of the sample problem is, to try and have something that's IETF oriented, relatively simple, not cryptographic, because I think that scares away a bunch of people. There's a lot of good work being done in formal methods to do cryptography, and that's great, but maybe we need something that's not. And again, for these kind of purposes here, to basically help people to understand how to apply the methods, and perhaps to help people who are developing those methods improve usability, and maybe even find out something about the problem itself. So the one that occurred to me that might be interesting, is perhaps some kind of subset or simplified version of IMAP search. So IMAP, we're all familiar with. Well, probably we're all familiar with having mail messages in the message store and using IMAP clients to do searches. And apparently a whole bunch of mobile clients actually make extensive use of search to save battery and local storage and so on. And there is a definition of, in RFC 9051, defines, it's the most modern IMAP RFC, and this section, along with some other ABNF, defines the search. And I guess we're kind of familiar with the types of things you can do with search. Search on various attributes of the message. One of the things that I wasn't aware of beforehand, but that's IMAP people I'm sure are, is that you can have some state in the search, and that the search results can be then referred to in subsequent instructions from the IMAP client to the server. And obviously, of course, also you can have multiple mail user agents that belonging to the same user. Let's say not necessarily different user agents or different users, but different user agents for the same user might be doing things at the same time. It's a relatively rich syntax, but not particularly complex, I don't think, in some ways. It has the state, and we also, I guess, have probably a bunch of people who have implementation and deployment experience that might help kind of point some of the people developing formal methods at interesting aspects of this to think about, or things that would be nice if we could prove something about them. So if we were to choose that, then what would we want to do? And again, this could be something that we do on this problem or some other problem. But if we picked some problem, we might want to get some people who are kind of familiar with, in this case, IMAP, and somebody familiar with some of the formalisms. Try and figure out how to document some subset of IMAP search that's interesting. Perhaps write that down in an internet draft or some other format, but an ID could kind of be sensible here. Try and discuss it in the research group. Maybe do some kind of last call type thing to stabilize it, but not necessarily publish as an RFC. And then try and encourage people to try and apply formalisms to that sample problem. Show us how they did it, how much effort it was, what are the results, and so on. And then again, the publication question that I think Felix asked at the beginning is how would you get those artifacts published? And ANRW might be one of those, a suitable place for publishing such kind of applications of particular formalisms to the sample problem. Or maybe, you document it in RC, that doesn't have to be the outcome. So I guess I'd be interested in feedback from the group as to, is this perhaps a useful problem to try and look at? And if so, anybody want to work on it? Are there other problems that might have good attributes that we could try and encourage people to work on? If people want to start a bunch of these things, that'll be fine. Not everything will kind of finish. But I think the idea of having some sample problem, I think it seems attractive. So my question is to people, does anybody like this particular problem or want to suggest a different one? And in particular, is anybody willing to do some work on either this problem or some other one? And that's all I had. So I'm hoping people will join the queue to say this is crazy or not, or I'd happily work on it or whatever. Karthik.
Hi. So just to understand, are you suggesting analyzing the RFC or something more abstract or?
Sure. What I'm suggesting is trying to document a subset of the IMAP search operation as a problem, and that's extracting text from the RFC and perhaps simplifying it to some extent if needed, and then sort of asking people to fire ahead and try and tackle this problem.
And what would be like is there a easy enough spec to understand that it should return the right results or something? I mean, what is the spec?
So basically, IMAP is when your mail client is talking to the message store and where you can select some messages, the messages from Karthik or the messages from last February, and you can do some combinations of that. And then you can also have other operations done on the results. So there's a stateful element to the results as well.
Okay. All right. Thanks.
I didn't hear Karthik volunteer to do anything. That's a pity, but maybe we'll get him in a minute. Felix.
Yeah, my question is maybe a bit connected to Karthik. So I wonder what kind of things you would like to investigate here. And this is actually, like my earliest question about the kind of artifacts was not about publication. And by you suggesting this IMAP problem to tackle, actually you answered my question already. So would you like to verify the correctness of this API? Because for the most part, APIs don't have a correctness notion in themselves, right?
So what I would, I can imagine that it's possible that various combinations of IMAP instructions using the search command could produce interestingly odd results. So for example, apparently if you do a search and one of a message is part of the results, and in parallel, a different mail user agent moves that message to another folder and back, you end up with different UIDs for the message. And so the results are no longer correct. And there could be a whole bunch of other corner cases that people who implement mail servers probably know about, and mail clients. I'm not aware that anybody has tried to prove anything about it. And it's a relatively simple problem to understand, I think. And if people could apply their formalisms to this and then demonstrate how you do it, I think we might have a good bit of learning.
Yeah, thanks.
Mark?
Hello, I'm Mark Petit-Guenin. So one of my comments was like the previous two speaker was that we need to know exactly what property we want to show, to prove here. But I wanted to talk about something slightly related. So as an engineer, I am interested in the usability of things, right? I am interested in that what are the right formal methods I should do that are usable for me as an engineer, right? The problem of usability is that this is in the eye of the beholder, right? Okay, sorry. Is that what is usable for me is not what is usable for another engineer or for another researcher or for someone else, right? And the problem of usability is that nobody can convince me that something is usable, right? I don't know what this thing is continuously flipping. So the only way for me, can you hear me?
Yeah, go ahead.
Yeah, okay. So sorry, I am interrupted by a stupid browser, which is doing wrong things. Yeah, so the only way for me to be convinced that something is usable is to see it, right? Is to see a use of a formal specific or a formal method for a specific things, right? And this is something that we do all the time with programming, right? The advantage of programming language is that there is a lot of resources. There is cheap books and so on. This is not true for formal method. Any book you want to buy on formal method is really expensive. There is very few resources for that. So I think that this exercise is a very interesting one because it would bring me a way to judge the usability of something on the problem that I know about, which is in this case IMAP, right? So I think that what would be really interesting is to have this one or another. I will say a little bit about this after. Is to have this thing with the property proven in many different formal method, right? With the source available. Well, one of the problems also is that a lot of papers that are used with Tamarin and all is that you don't have access to the source. You don't see how this thing is formalized. You don't see the proof. And for some few exceptions, you have no way to judge if this formalism is easy to use or not. So I would really encourage to choose one. To put somewhere, it's like Rosetta Code. If you know Rosetta Code, this is exactly the same. They have one problem and it's implemented with all the possible programming language. So in my opinion, it would be very useful to have that to let people decide if it's usable or not for them. About the example of IMAP, personally, I would have a slight preference for a protocol which we already know that is wrong, that is incorrect for some property, because in this case, we don't have to do the formalism and searching if it's true or not at the same time. I think it would simplify a little bit. Thank you.
Thanks. Karthik?
All right, I popped myself up. I'm still not volunteering to do something, but I would say that I think this is, IMAP has a nice feature that it's clearly something a lot of people care about. It feels like real world. But if I were to get a student to do something like this, I mean, if I just ask them to go look at the IMAP RFC, it just scares the hell out of people. I mean, we have done this before. It's just to understand the context around the search is already too much. So if in such a problem description, we could also like offer from the engineering or the IETF side, all right, you know what, we'll just frame for you this minimal thing, even in text, or we'll just extract out the relevant bits of the RFCs. This is all you really need to know and formalize. And if you do it, then you get to say that, oh, I actually formalized a chunk of the IMAP as extracted by experts of the internet. So it's not like completely a fake thing that I analyzed, but I don't actually have to go and learn everything. So I mean, making things a bit more self-contained would, I think, would make it possible to put an intern or a student or something like this on a project like this, I think, which is the way I see this going forward.
Yeah, absolutely. I absolutely agree. That's why, if we did proceed with this problem, I think the first thing to do would be to kind of figure out a sensible subset of not even IMAP, but just a sensible subset of IMAP search and document that in a way that's consumable for the a student you might ask to try and tackle this. And I think the point that Mark just made also is probably a good one, is trying to include something that's problematic in the subset you document that we know about. That would be a good thing. And I don't know if there is such a thing or not associated with IMAP search. So Karthik, did I hear you promise to put a student on this if we can produce a crisp definition that's useful for a student?
I would certainly advertise it to the groups of students that I supervise who often are looking for a project which will have real world impact, but they just don't know how to get started. So.
Okay, so a possible promise for the future. That's probably as much as we can ask. So I just want to check also, are there other problems that people have in mind that we might be worthwhile trying to encourage the research group participants to investigate? Again, it's entirely fine to have top of the head answers here, and especially if people are willing to have a look at something between now and the kind of next IETF meeting timeframe. So Mark, yeah.
So one thing that I proposed to formalize was RFC 3261, which is SIP. And the reason for that is that there is a lot of bugs that were discovered in RFC 3261 and that were fixed, right? So there is at least 2 fixes that were done. And this is in the state machine. There is one state machine which was absolutely wrong, well, partially wrong. So it could be a good place. I am biased, obviously, because I work for the last 20 years with SIP, so I know the thing very well. But it could be an example of something to formalize that we already know is wrong. We know exactly what is wrong, and we know that was fixed. And there is multiple papers that you can think with people refinding the same error and explaining the same error. So as I said, if we go with the idea that we can have multiple different formalism to formalize this, to be able to compare them, this could be a simple thing, because now we don't have to search. If it's wrong, it's wrong. It's obviously wrong.
Great, thanks, Mark. Felix?
Yeah, first, before I make my actual remark, I'd like to comment on what Mark just said. So I think it always depends on what the goal is of why are we looking at something with formal methods. And especially with existing problems, I think you often run into the problem of knowing what you look for, and then all of a sudden the tool works remarkably well. So I think it's better to go to explore something that we can sell to other people. And for that reason, I'd like to support the IMAP idea a bit more. And secondly, now my actual comment for which I raised my hand, you are asking for off the top of my head ideas about other things to work on. So what I work with the Tamron prover, so I use formal methods for security. And what I found very interesting, and I knew about it, but it wasn't on my mind anymore, is formal methods for correctness, right? And I guess this is much more what you'd go for with the IMAP example. In the for security part, I recently was wondering how little protocols actually, like specifications, actually have a usable security section for formal modelers. So I think also specifications need to be a bit more usable for people who want to investigate the security. We recently had a master thesis presentation where the student analyzed some protocols, and the security goals were just, you couldn't understand it. And half of the work of that student was to actually come up with sensible security definitions. I talked to a colleague about this already, and they pointed out to me that there is an RFC already on how to write security sections in RFCs, something along those lines, and it is okay, but I wonder where the gap is, especially because oftentimes when you look through RFCs, I still wonder, okay, what are they actually doing? And figuring out why people cannot write these sections would be, or do not write these sections. Maybe they can, but why people do not write these sections would be something interesting too. This is a much less actionable proposal. I think it's much concrete, but it is an idea that I had. Point.
Yeah, sure. Yeah, and I totally agree that aiming to figure out what the hell is the meaning of security consideration sections of RFCs, that's a very much a variable thing. So, Jonathan, you're in the queue.
Yeah, I wanted to absolutely second that. Most RFCs that I've ended up analyzing, the security considerations do not appear anywhere in the security considerations section. And you mostly find them smeared across a large document. I do think something maybe further down the road we could think about is writing something like a BCP on how to write security sections. But I think before we can do that, we'd first have to have something sensible to say. We definitely know when they're good, and we definitely know when they're bad, but there are a lot that are sort of in between. So when we've got something useful to say, I think that might be worth trying.
Sure, and bearing in mind, of course, that BCPs are things for the IETF and not the IRTF as well, etc. Okay, cool. Any other takes on this? So I think there is a tool called the show of hands tool. I'm going to ask a question using that to see if I can elicit more input. And let's see if I've done this right, because I haven't done it for a while. So the question here is there's a show of hands tool that you can click on. And the question is, should the research group spend time trying to identify and document a sample problem, whether IMAP or something else? And if you click the raise hand button, if you think spending that time would be useful, and if you think that spending that time would not be useful, then click the do not raise hand button. And in the nature of these things, it's common to try and ask at the end if somebody is in the contrarian kind of side of the poll, if they're willing to say why. But actually, we have 0 at the moment, so that doesn't apply. So we need to stay that running for a second more, and we can document the results. It looks like we have about 33 people in the meeting, and about 21 people seem to agree that trying to spend time identifying and documenting a sample problem is worthwhile, so that's good. I think probably I'm open to people making other suggestions, but a question might be, well, I don't know, Jonathan, I'm not sure if you have any thoughts. Maybe the best thing the way to proceed with this is to just bring that up on the mailing list, and see if people, with a bit more consideration, have other ideas for what kinds of sample problem to work on, etc.
Yeah, I think bringing it up on, I think bringing it up on the mailing list is probably going to give people enough time to think about other sample problems. But I am quite a big fan of the IMAP search one. I think that's quite if we can scope it well, I think that's quite a good choice.
Colin? Oh.
Yeah, I can figure out how to work this eventually. I mean, there were a couple of comments earlier about sort of the different classes of problem. So proof of correctness versus a security proof, for example. I'm wondering if we should maybe give thought to the different types of things you can prove and try and identify a couple of different classes of problem. Maybe a straightforward security thing versus a straightforward correctness thing versus whatever else there might be.
Yeah. Okay. Good point. So I guess as we, I mean, I guess with, as chairs, we can take an action to try and craft a mail to the list saying, kicking off this discussion, and I think that's a very fair aspect that we should include as people think about what to do. Okay, I don't see anybody else in the queue. Colin, I think you're able to drop from the queue, or I can boot you. In that case, I think we've covered this topic, unless somebody else wants to jump in. And I think the next one is Jonathan, if I'm correct.
It's always very slow.
Are you? Am I sharing the slides, or are you?
I was going to, but you look like you've already done it. So.
Oh, okay, and I can give you control. So there you go. Now you got control.
Perfect. Thank you. Okay, so this is basically a talk that's going to say these are the issues I think we have currently in formal methods that make them not less usable. And the goal of this is for people to first say, no, I don't think that's an issue, or to say, oh, you've missed out this other big issue. And then second, for people to say, this is a thing we could work on that we could actually achieve. So this slide, this deck has 8 slides in it, but about 15 words. So hopefully I'm going to get lots of audience participation. There we go. So I would say the currently biggest issues are issues with tooling, pen and paper proofs, issues with publishability, issues with training, and issues with verifiability. And I'm going to quickly go through all of those, and then hopefully I will have a queue. So when I say tooling, I think one of the biggest issues is a lot of the tools have UI UX issues that make it very difficult to achieve a proof that you want. And that's not related to the functionality of the tools. We have lots of tools with amazing functionality, but there are a lot of issues with UI UX that make it incredibly difficult to actually use them. Even things like color palette choices, making it impossible to see what the tool is trying to tell you. The next one that I think is really important, and I think the only solution is to stop doing this, is pen and paper proofs. Pen and paper proofs are much easier to write down, but as they become longer, they basically stop being proofs and just become proofs by assertion. When I recently saw a paper which had an 80-page algebraic proof in it, and when the authors send that for peer review, no reviewer has the time to go through and actually check an 80-page security proof by hand. And so I think one of the things we need to do is make it so that the tools are so good that nobody would choose to do a pen and paper proof. Stephen.
Just a meta question. Did you want questions as you go, or not?
That would be ideal. Yes.
Okay. In that case, I even have a question.
Excellent.
So, what you say is clearly something with which it would be hard to disagree. In the context of this research, how would improving the situation with pen and paper proofs, how would that manifest itself in the research group? What might happen?
So
and I'll also encourage other people to jump in and interact on this as we go.
For sure. So the thing I really think, to sort of put my cards on the table, obviously what I think is no one should do pen and paper proofs. In practice, what I think that means is the onus is on tool developers and the users of these tools to make the tools so good and so usable that people would choose not to do a pen and paper proof. You can't force somebody to not do it. The only thing you can do is say, here is a tool that is so good that you would just do it naturally in the tool, and like has good training materials and so on. And so I think this sort of is a goal maybe for this research group, is we know we've achieved usability when we see people using the tools and we see people not doing pen and paper proofs anymore. Any other comments? Chris Patton, sorry.
Sorry, I just Sorry, I just clicked all the buttons trying to get myself to talk. I just wanted to say, in defense of pen and paper proofs, they are a good way of doing just your own security analysis of your protocol. If you can convince yourself a reduction can be done, then you're increased confidence. But I mean, I think the end goal should be a machine checkable proof for sure. But I think along the way, people are still going to write them. I wouldn't ever. I can't imagine starting with trying to do a mechanized proof. That's said, I lack any experience with these tools.
Yeah, so I completely agree that like doing a proof sketch is 100% necessary. Certainly, if I'm trying to do a proof in Tamarin or anything, obviously I start on paper or on a whiteboard actually, but that I totally think of as a sketch and not as this is actually a product that I could show to other people, because I don't think it's actually a proof. I think it's a shape. Gurgley. I'm not getting any sound.
Okay, my body is that the training material should be part of the user experience, because most of the time documentation is not a learning material. So they just write down all the features, but that's not how, so they don't tell you how to carry out what you said, a middle-sized proof. Okay, that's it.
Yeah, I think that's very true. I think documentation and training materials are both important and are definitely different. Chris.
Yeah, so when working with SSPs on paper, so one reason I wanted to work with SSPs was that code of key exchange protocols was so huge, so that, you know, like if you want to come even close to the real protocol, I'm not even talking about an actual implementation, but just like have all the protocol features, it's just too much. And maintaining a huge code base on paper, on a paper proof, it's absolutely absurd. Like you change your Oracle here in your LaTeX document, and then you need to change it in all the, like, you know, 15 places where it shows up in your proof. So whenever you have a huge like code base of a huge protocol to deal with, it's absolutely painful on paper. So I think that when the objects that we prove things about are so huge that we cannot keep them in memory, I think this is really a point when you know, this tooling really makes things easier, and you know, hits this point where doing a pen and paper proof is just no fun. Of course, you still use pen and paper in developing the proof, but I think for really large objects, you will want to use this kind of tooling. So that's that's just where we come from this frustration of saying, no, you cannot do this with pen and paper. So just to say that I don't know.
Yeah. With pen and paper, this is just my feeling. With pen and paper, what I have to keep in memory is the formalism and the whole proof set. With a machine checkable proof, all I need to understand is the formalism, and then the computer says yes is sufficient, right? I don't need to understand how the mechanics of the proof behind the scenes work. That's not even interesting to me. Well, it is interesting to me in a completely different sphere. But I care very much that this is what we have proven, and I think that's the key thing. Pen and paper proofs require too much memory space to understand. Are there any more comments on pen and paper proofs, or shall I move on? Felix.
Maybe not really a comment on pen and paper, but why isn't Isabel the tool you're looking for?
Isabel Hall.
Yes.
I have to admit I've never particularly tried Isabel, but the tool I use is Tamarin, and it has some really bad UI UX issues, and I would use Tamarin a lot more and for a much broader range of things if I could fix those issues. And so I think one reason a lot of people don't use machine checkable proofs is the tools can't handle it. And not for reasons of like, this is unprovable or they don't have the feature, but because of the tools have, you know, issues, bugs, whatever. Chris.
I was, can you hear me? All right.
Yeah.
I was actually thinking that kind of Tamarin is one of these good examples. Like I thought that, you know, like I saw multiple people with minimal support and background learn Tamarin essentially by themselves from the documentation, analyze and model very complicated security properties, etc., etc. So I like and you know, like make sense of these graphs, etc. So I thought Tamarin was actually one of these very good examples in terms of usability and user experience.
So I as much as I like to hate on Tamarin, it is the best tool in my opinion. That doesn't mean it's good; it just means it's the best. But you know, it's things like, you know, it produces those very pretty like state diagrams of where you are on your proof, and the boxes, you might not have noticed this, have different colors, and they're all very different, slightly different shades of green. I was using Tamarin for 3 years before I even knew that those colors were supposed to be different. And they're supposed to be providing me with semantic information. To me, that information was just not there because I cannot see
right.
I couldn't even see that they were supposed to be different, right? Like that was a choice in the design, easily fixable, that there actually is like a branch that has a way that lets you change the colors. But like, that's a usability issue that has nothing to do with the technical tool.
Right. Sorry, is that the like? So that's.
Oh, I can keep going. There's like a dozen of them, but.
Okay.
But you know, as an example, like, or you know, another one is when you get to a big proof, it repaints the entire screen for every step you do, and when you're doing the TLS proof, when you get to step 749,999, it takes several minutes to render a one-line change. On a machine with a decent GPU, it takes several minutes to render a one-line change. Like, you don't need to re-render the entire proof, right? By definition, it's not changing. But anyway, so issues like that, which are nothing technical, they're just like UI issues.
Right. Thanks.
Okay, any more pen and paper proof comments? No, in which case I have a few more slides. Oh yeah, this is another one that annoys me immensely. Publishability. Quite a lot of formal analyses end in, yes, this is fine, or we didn't find any major bugs. And even if you go to journals that say, oh, yes, we accept negative results, you'll be told your proof is not novel. And it is very, very hard to get your proof that this is okay published, even though that would be very useful for the community to say, here is a demonstration that this tool is, that this protocol is secure, and we can use it. And so what I've taken to doing is sneaking formal analysis into papers, deployment papers or systems papers, which means they don't really get checked by somebody who's an expert in formal analysis. But it is basically very difficult, if not impossible, to publish results that are not, we broke this protocol. Any comments on publishability? Or actually, let's just come back to the end. Oh, Felix, sure.
Yeah, I know what you mean, and you definitely have a point, but I still would like to argue against that point a bit. From my experience, my limited experience in publishing, you have a quite high barrier for security critical designs in publishing that you could publish as a design, and that get often rejected if you don't come with formal proofs. I think even non-formal people start to get a better feeling of kind of which designs are in the ballpark of being provable, right? Like if you design a brand new OS, what do I know? OS thing, right? Usually people don't say, oh, you should get a proof, right? But if you design a new protocol, I think you could get rejected for not having a formal proof. Which just means we have a problem of verifying the things that are already around. Because in that space, there definitely is an issue in publishing positive results.
Yeah. So I agree, yes, if you are also publishing the design, but quite often a design has been published and someone says, oh, can you do an analysis of that? And I'll check it. I'll say, yeah, looks great. Never gets published. Like the DC paper, which I'll talk about, the DC presentation that I'll talk about at the end, I did that analysis like 3 years ago. I tried to get it published for a year and then gave up. Okay, next slide. There we go. I think this is one that we really can work on, training. On the previous slide, the thing we could do is we could publish these artifacts ourselves. Training. A lot of people have told me, oh, I tried to do a formal analysis, but I couldn't get the tool to work, or I got a state space explosion and I didn't know how to fix it. And there's sort of nowhere to go between this is a really trivial example and this is us using all kinds of weird hacks to trick the tool into working that you wouldn't necessarily know how to use. And I think one thing that would be really worthwhile for us to work on is say, here are some like intermediate difficulty examples, and we'd sort of just host them on the wiki or some kind of articles. There we go. Yes. Another one is verifiability. And I think, Stephen?
Sorry, back one, Jonathan, on training.
Yeah.
I'm just trying to formulate the question properly. What kind of timeline would make sense for the research group to try and make progress on that? Is this something that we could try and encourage people to produce some training materials in the near future, or is this something where it's kind of going to have to happen down the line some?
I mean, one interesting to me would, and this is me postulating standing on one foot, but you know, we could do a hackathon training session, right, fairly cheaply at IETF-117, for example. Or we could do something more, you know, just producing the very simple example with multiple implementations in different languages I think we could get started with that fairly easily, because hopefully an intermediate example would only be a couple of days' work to produce by an expert. But yeah, so I think we could definitely start seeing some kind of output before IETF 117 if we can find people who are interested.
And so I guess then the question is anyone interested? So is there anybody who would volunteer, I guess, to try and put together some training materials that could be presented either at the hackathon weekend before the IETF 117 or in some other way around that time frame, which is the end of July? Does anybody want to jump up and say, hey, I would be willing to do that?
Felix, are you planning to go to the IETF in SF in San Francisco?
Yeah, that was I was about to write it. This would be a Prague thing.
Okay, so that's so Prague is November this year, is it?
I think so, yes. I don't know whether I can come, but I will definitely not come to San Francisco.
Right. Okay, so then, so then modify my question, and in the context of July or November this year, does anybody feel that they'd be happy to do a bit of work to present some training on some of these formalisms that some people at an IETF meeting might find valuable?
Okay, well, I mean, just to make sure we'll have something, I'll try and put something together for Rosette for November as well, if we're going to aim for November.
Yeah, okay. So I wanted to volunteer with my last message, just not for San Francisco.
Fantastic, Felix. Thank you.
Colin and then Yaron.
Hi. So I certainly don't have the expertise to volunteer anything. It strikes me that as well as sort of things like hackathons, we might be able to find people who are at universities near some of the meeting venues and invite them to give a tutorial. You know, if we have a meeting in France and find someone at one of the relevant groups at INRIA and invite them, for example.
That's certainly an option. I mean, Prague is relatively near France.
Yeah, it's pretty close.
Although annoying to get to by train. Okay, I think we'll take that to the list and see if we can arrange some kind of training.
You still have Yaron in the queue there, Jonathan? Sorry, Yaron?
Oh, sorry, Yaron.
Thank you. So I'd like to tie this idea into Stephen's presentation and the idea of an example and IMAP. I think that successful training with people from across the IETF could lead to ideas that are more relevant, more modern, and more likely to produce actual failures than IMAP. And so
so Yaron disappeared for me.
Yeah, I think you got cut off, Yaron.
But he can correct me, but I think the point he was making was that if we had some such training, that might help to identify better sample problems than the IMAP being suggested so far. That's a fair point.
Yeah, we could send an email to some mailing list somewhere. I'm not sure what it would be, and just say, would people be interested in formal methods training? Bring your own problem along. You know, we'll just try and get some experts to hopefully be there and try and help them along.
Okay, I think the takeaway there is try and aim for something for November.
Sounds good. Okay. Verifiability, and then I only have one more slide. Verifying these proofs once you're given a mechanized proof can actually take quite a long time. The TLS 1.3 proof takes a couple of days to run on a fairly beefy GCP box or cloud compute box. And it can cost quite a lot of money to actually rent a box for that much time. And I think for pen and paper proofs, I've already mentioned, like actually checking an 80-page proof would take months. And so these are sort of beyond the capabilities of peer review. And I think one problem with a lot of formal methods is no one ever actually checks that the proof is correct. In terms of things that we could do in this space, all this work from the zero knowledge crowd and all of the work into probabilistically checkable proofs, it might be worth thinking about, is there a way that we can produce an artifact that lets you check that a proof is correct very, very cheaply without having to rebuild the proof from scratch? And so if that inspires anyone to, I don't know, kick off a research project, that would be very cool. And I think I've got one more slide. Yes, one more slide, last slide. Does anyone else think something else is important or vital for usability? Some suggestions at the bottom. But yeah, this is open floor. Is there something else that you think is making formal methods unusable or difficult to use? Felix.
Yeah, I have two thoughts. Before I answer your question, I'd like to comment your last point regarding verifiability. So I completely share your concerns that formal proofs are often not looked at enough. But I'm not sure if this is the biggest problem we have, because like you throw the model and proof at a machine and it returns true or false. I don't think that this is the problems that many proofs have. I think many proofs terminate because most authors, I hope and I believe, are actually honest enough to make them terminate. And a malicious author, they could cheat in other ways, which is like teeny tiny details of their model. So I think the problem is rather like, are your assumptions all well documented, and are they like, is your model actually matching the real world? I think this is a much bigger problem, and there you just need to put in the time. I don't think there's any shortcut to that.
So I think with TLS 1.3, that's quite a good example in point. Our proof, we published our proof. Any of the reviewers could have put that into an AWS box and run it. But it would probably have cost them at the time more than $500. And so I would bet money that none of our peer reviewers for that paper actually did that. And I think that's actually quite a significant failing, right? Like, we're supposed to have been peer reviewed, but actually no one, and it's not that we were being dishonest or that our proof doesn't terminate, it's that actually it's just a really long proof.
Yeah, I know. But even if you were dishonest and your proof wouldn't terminate, and you knew that your peer reviewers would check it, you just cheat in your model so that your proof just terminates, right? It's not hard to make a proof terminate. It's hard to make a meaningful proof terminate. That's what I mean. And now to your question about other things. So again, a very high level thought, but I think maybe this connects a bit to understandability. But I think a lot of formal methods tools suffer from their low levelness of their input languages, right? They are you're often very close to the mathematical concepts that underpin these tools. And so to know, for example, how to implement a loop in Xamarin, right? It takes some mind yoga. And I think it's super tough to make this better. But in an ideal world, I think many formal methods tools would provide more abstractions out of the box that match the intuitions that engineers have of the systems.
Yeah, that's interesting. Although how you would achieve that without building some kind of transpiler, I don't know. Like that sounds like a very difficult challenge. Any further comments, thoughts, ideas? Anyone have any suggestions for how we can tackle any of these topics or others, or things that we could actually contribute here?
So I guess we have one concrete thing on the training is that we're a few people are interested in doing something in the November timeframe. That's good. And I think that was Jan.
Okay. I think so when I dabbled with Tamarin, it allowed me to, I think, really generate proofs that were supposed to be easily and quickly verifiable. But I think when I tried to do it on a later version, a few months later, it didn't verify anymore. So maybe this is not worth it. But I think that also was like 4 years ago or something. Another thing, I think SMTlib can give you unsatisfiability proofs. So yeah, I think to some degree, like the foundations already provide the features. So maybe it is just a question, just in quotation marks, a question of like developing the features and the tools.
Yeah, the particular thing about verifiability was I was just very inspired by some of the zero knowledge proof systems where you literally just send 3 elliptic curve points and suddenly you can be sure that every step of this huge proof was run correctly, and so I can verify the proof was run correctly in like milliseconds rather than days of expensive computer time. Exactly. And like recursive snarks and all of that, like fabulous magic. Any further comments on things we could actually do? Chris?
Just to say that we're potentially interested in contributing to training, but not at the point where we can commit to anything, because this is a major time commitment to produce reasonable teaching material.
Well, yeah. I mean, would you be willing to show up in November and just like help out with people who show up?
Well, if we have a tool that is published by then, I mean, let's start.
Okay, fair enough.
So I think it's too early to make a commitment, but is it possible to jump in later?
For sure.
Okay.
Okay. I think that's everything. Are we gonna go with the if time permits? Excellent.
I suspect we may be at the time where time doesn't permit for the second time. I just wanted to go back to the chair slides.
Very good.
For a second. So if we look at our agenda, I think we've covered the first bunch of things. I think we're going to have to delegate to the next time for delegated credentials. But what I did want to just check is that are there things people want to work on in the research group and would be interested in trying to collaborate with people, or just do it yourself? But especially if they haven't been mentioned. I think we'd like to kind of start to, as the research groups gets going, see the level of activity kind of bump up a little bit. Doesn't have to be, going at 100 miles an hour, but it'd be nice to see things happening. So in particular, if there's things that didn't come up already today that you would be keen to work on, especially if you're looking for people to work with, it'd be really good to hear about that now. So if anybody wants to join the queue or go to the mic to say, you know, I want to work on this and we haven't mentioned it yet, this is the time to do that. We have a few minutes, so. So I don't believe that we've mentioned everything that people might think of working on. So perhaps that indicates that people are, after nearly 2 hours in the meeting, are a bit kind of tired of it. But I think, you know, there is the opportunity to kind of speak to the group of 29 of us still here, saying that you think such and such a thing is worth working on. Met with crickets. Colin.
So I don't have any particular thing that I want to mention now, but maybe one of the things the group could be doing is helping to sort of capture a list of protocols where people want input, as well as a list of techniques and things where people can you know be trying out particular techniques.
Yeah, fair point. And I mean, I guess so I mean, we could probably try and address that by trying to organize to do another pass on the wiki. I think Chris Wood did a bit of work on the wiki previously. And so, you know, that we could probably try and arm twist there a bit. Is he still at the meeting, or is gone? Maybe Chris is gone.
Yeah, I mean, collecting the stuff on the wiki is really important, but also just highlighting in meetings and in various IETF venues. You know, if people have protocols where they need input, this might be a good way of connecting protocol designers to people with formal methods expertise.
Sure, cool. Thanks, Colin. Good points. And so I don't see a pile of people jumping to the microphone. I don't think we have time to do justice to your delegated credentials presentation, Jonathan.
Yeah, I think perhaps not.
So I guess that brings us to the any other business kind of part of the agenda that wasn't there but is now. So do we have any other business that people would like to bring up? Complaints, things that things you hated. You want the chairs replaced already? Nothing at all like that, no? Not seeing it. Okay, so I think we have a couple of actions. I just wanted to check. As far as I know, Felix and Karsten were helping take the excellent notes. If I'm missing somebody there, please tell me your name or add your name to the note takers, because it's always good to credit people for doing that. And otherwise, I think I'm not. Karsten, yes.
Yeah, I just wanted to say that many of the notes are from a person who knows nothing about formal verification. So you may want to read those notes before I completely misrepresent what you were trying to say.
Karsten, I'm highly confident in the capability of your note taking, so I'm sure it'll be perfect. But we will certainly give them a good look over before we hit the publish button on them. Okay, so given that we're 2 minutes to the hour, and I don't see anybody else in the mic line, I guess I'd like to thank everybody for joining, especially the people who made presentations. We'll kind of trawl through those notes, look for the couple of actions as chairs, and try and bring stuff to the list with a view to meeting. I guess, sorry, I should check. We're planning to request a session for July IETF. If anybody thinks that's a bad plan, then just say so. But our default is to request a session. But with that, I think, Jonathan, anything else, or are we?
No.
Okay, with that, thanks all for taking part. Look forward to doing more stuff on the list and in future meetings. So thank you and goodbye for now.
Thanks, everyone.
So, oh, Jonathan's gone. All right. Oh, never mind. Oh, Jonathan's not gone. He's gone. Yes. All right. Never mind.